how to build the ultimate in-cabin experience. My name is Ashley McManus, and I'm the Director of Marketing here at Affectiva, and I'll be your host today. With me, I have Damien Scott, Chief Commercial Officer at Renovo. So before we begin, some housekeeping items. You can tweet during the event using the hashtag AffectivaAutomotiveAI and tweet us at Affectiva. If you have any questions during the event, please write them in our Q&A section located in the bottom right of your screen or ask us in the chat box. Technical difficulties, please send us a message through WebEx or email us at events@affectiva.com, and we'll do our best to work with you to resolve the issue as we have quite a few registrations today. Also, please note that we are recording the webcast and we'll make the recording available to registrations before the end of the day. So before I hand it off to Damien, I wanted to give you a little bit of background on Affectiva and who we are. Affectiva is a MIT Media Lab spinoff and is the pioneer in emotion AI, the next frontier of artificial intelligence. Our patented AI platform uses computer vision, audio analysis, deep learning, and detects complex and nuanced human emotions and cognitive states from face and voice. This is all powered by the world's largest emotion data repository of over 6.5 million faces, analyzed across 87 countries, amounting to more than 50 billion data points. So to give you some context on why we are here with our partners at Renovo today, AI in automotive has historically focused on what's going on outside of the vehicle, but recently we've seen OEMs and Tier 1 suppliers are beginning to turn cameras and sensors inwards, using AI to gather insight on what's going on with the people inside the vehicle. And looking ahead to the evolution of autonomous capabilities, consumers will shift away from assessing a vehicle's driving performance to focus on the best in-cabin experience possible. To improve road safety and to offer a stellar transportation experience, there must be a deep understanding of driver and occupant emotions, cognitive states, and reactions to the driving experience. Our solution, Affectiva Automotive AI, unobtrusively measures in real time complex and nuanced emotional cognitive states from face and voice. This next generation in-cabin software enables OEMs and Tier 1s to monitor driver state and measure occupant mood and reactions. So I am going to hand it over to Damien. And while he's getting set up, I will give you a little bit of background on him. Damien Scott is the Chief Commercial Officer at Renovo Auto. He joined the company in 2016 and is responsible for partner relationships, go-to-market strategy, and all other commercial and strategic development initiatives. He has previously worked with a wide range of firms in Silicon Valley at the forefront of transportation and energy technology, including with Google X and grid edge optimization startup Verintech. Scott is also the co-founder of the Stanford-Harvard Forum on the Future of Transportation, SHFFT. So without further ado, I will hand it off to you, Damien.
Great. Well, thank you very much indeed, Ashley. I'm just going to get my slides up here. When you have a system that can react faster and actuate systems in a vehicle faster than really any human can do. And so we found this really useful to push our technology to the limits. And as someone that comes from the racing world, I have a strong belief that that's a very good path to start with in order to stress test and really understand the breaking points of technology in a safe environment. And so that work has really transitioned into our core focus, which is on building Aware, a platform for automated mobility, which is really enabling what we see as one of the most important transitions that's happened in the automotive industry, which is taking the driver out of vehicles and enabling systems that no longer require individual vehicle ownership, so on demand and so forth. This requires a lot of pretty complex technology, data management, bringing together third-party technology nodes, both the hardware and the software. There's an absolutely critical safety piece that these systems need to be reliable and testable and provably safe. Okay, great. So, yeah, the video you're seeing up on the screen at the moment is one of the vehicles in the Renovo fleet, which is run on software, various third-party technology nodes, hardware and software interacting with that system, and really proving out the different components that we believe are necessary to bring together a full automated mobility service. And so this is really something that we've seen before in a number of different technology sectors, where initially a new product or new product paradigm emerges, and frequently they'll start with 100% vertical integration in order to deploy a minimum viable technology or service. But very quickly, horizontalization, where third-party technologies can interact with platforms, is really what leads to substantial innovation and scaling. And so we've seen that with computing systems like Linux and proprietary operating systems like Microsoft that ushered in the PC era. And in the mobile phone world, Android in particular has been transformative in bringing about the smartphone revolution. And so it's our view at Renovo that the same is going to be true for automated mobility. And today there's really no fully open operating system for robotaxi service stacks. And this is what we do. We fill that gap by building it. So I want to spend a couple of minutes just talking about the opportunity for automated mobility, or some people call it robotaxis. We believe this is really transformative because it has the potential to become the cheapest, safest, and really most convenient form of transportation for people that are in denser urban and potentially suburban environments. And just in the US alone, this is potentially a $1 trillion market. And the fact that the transformation could potentially happen in a little over a decade is really quite astonishing. And I think many people in the automotive and transportation industry recognize this is really a once in a generational change that is happening. And so it's really our belief that it's this combination of different things that come together to bring about automated mobility. The removal of the driver and automation of the driving function is really a critical catalyst of this. And that happens in a geofence context. It's very, very difficult to build a system that can safely and reliably handle all of the possible circumstances and environments that exist in a very large country like the continental United States. And so automated mobility acting more like a cellular service where it's limited to certain operational areas, we think is really the paradigm for the foreseeable future. And then finally, these vehicles will be electric. Things like range anxiety really go away if, as a consumer, you're just purchasing a ride. You don't really care what happens after you get out of that vehicle. And finally, and really importantly, these vehicles and these services will be provided in a fleet context and not an individually owned vehicle. I'll dig into that a little bit more, but it really comes down to economics. So today in the US, a ride-hailed service is, depending on the city, around $2 per mile. And that compares with owning and operating your own vehicle, insurance, fuel, depreciation, and so forth, which is about 80 cents a mile. And still, many people are giving up the ownership of vehicles because it's more convenient than for parking to use ride-hailed services, and they don't have a significant commitment in purchasing the vehicle or financing it through a lease agreement. The potential really for automated mobility and robotaxi markets is to drop that price well below what it is for ride-hail services and substantially below individually owned vehicles. That's really because you're removing the costs of that additional human driver. And so those economics are really potentially quite transformative. A data point from Rocky Mountain Institute, looking at residents in Austin, even at $1 per mile, a significant number of Austinites would use an automated service pretty extensively. Over 10% would completely rely on that, giving up their vehicles. And so this is at $1 per mile, within 5 or 6 years is a very substantial market just in the US alone, topping out at over $100 billion. And you can see here, these are kind of key urban locations and the revenue potential from them. So it's really no surprise that many of the leading firms in the sector are aggressively investing in technology to establish a position and a leadership position in this new paradigm of automated mobility. And so this is a slide from General Motors, a presentation last year, and they are similarly characterizing the automated vehicle market opportunity where the cost is less than $1 per mile at about $1.6 trillion. So I think it's really important to draw a distinction between the different levels of automation. There's a little bit of confusion and sometimes misuse of terminology in the sector. The Society of Automotive Engineers describes automation across 6 different levels, from none to full automation. And automotive mobility on demand really sits in level 4 and 5. As I mentioned previously, it's only when you take out a paid driver or the individual that is taking the journey that you can bring about these fleet operated services and realize some of the really exciting economics. And so why is it that robotaxi fleets emerge well before individual vehicles that can drive you around and drop you off at work and go off and do chores for you? It's really, again, it's an economic argument that in order to automate these vehicles, there's a substantial amount of expensive hardware and software that goes into each of those vehicles. And that can be split across multiple rides if these vehicles are being used a lot of the time. Whereas for a luxury car that an individual owns, which is typically used between 3 and 5% of the time, the cost of making that vehicle a level 4 or level 5 vehicle is going to remain high for a reasonably long time. And so it really comes down to utilization, that if we are going to equip these vehicles with complex sensors and compute, they really need to be used as much as possible in order to amortize that cost across a large number of rides. And so when you think about automated mobility, there's a range of different components that come into it. First is there needs to be a system that can drive the vehicle. There's the vehicle itself, which relates to the subject of today's conversation, the in-cabin experience. There's the asset owner and the fleet managers. So these are the entities that are trying to realize the value of these expensive assets that they've purchased. There's demand aggregators, which are going to be the entities that own the relationship with the end user of these services. And in some cases, the layer 3 and 4 may be the same entity. We're seeing a lot of services that are spinning up that are vertically integrated. Again, as I was saying earlier, when one looks back at other technologies, typically these break apart and get best in class operating in each layer. The fifth and final layer is what happens with content inside the vehicle, commerce and passenger experience. And so again, this is really what Renovo brings together. We see these different layers becoming necessary to enable true automated mobility, and we pull them together. So it's our view that these services are going to arrive years before individually owned automated vehicles. They will provide significant benefits to those that use them and provide many positive externalities to society. As I mentioned, the vast majority will be electric, and the capabilities of these vehicles to improve safety of other road users and their occupants will be substantially better than human-driven vehicles. And so for us, we really want to be the operating system that powers the majority of these miles by 2025. Automated mobility is about way more than just the robot that is driving the vehicle. And the cabin experience really is something that for the first time in a while is possible to really rethink, starting with a blank canvas. And there's a couple of different elements to it. One is, what are the physical designs that become possible once you remove the constraints on having a driver in the vehicle, having that driver maintain appropriate visibility through the windscreen to side mirrors, making sure that that driver is not distracted by any in-vehicle entertainment, by other passengers, by other physical structures that are inside the vehicle. Certain constraints still remain, things like safety of the occupants, making sure that in the event of rapid deceleration, emergency braking, or an accident that couldn't be prevented, that the passengers are maintained in as safe a state as possible. Second is how the vehicle is going to drive. Ultimately, it's the occupants need to feel comfortable. If they're going to be doing different things in the vehicle, it needs to drive in a manner that facilitates that. There's a question of what you can do in the vehicle. The possibilities really open up as one thinks about what the physical design is, with the occupants not requiring any participation in the driving function, supervisory or direct. Their time is freed up to potentially undertake a whole range of other activities. And then fourth and finally is personalization. That for many of us today that own and drive our own vehicles, we can personalize those through specific customizations. We can program in our favorite satellite radio channels. We can set seating and temperature and so forth. In a fleet-operated context, these vehicles are going to be picking up and dropping off very different passengers throughout the day, and ensuring that when a passenger gets into that vehicle, it is optimally configured and personalized to them is going to increasingly become one of the differentiating experiences. So just a little bit more on the physical design. You can see here there's a concept from Mercedes, the F015. And it really contemplates this environment that starts to look a little bit more like a sort of luxurious living room or executive jet, or something along those lines. And I think that this is really an exciting opportunity for car makers and car designers and potentially new entrants to think about and really rethink what the interior physical cabin could possibly look like. With this design, there's some sort of conventionality to it, that you've got windows and you've got skylights. But imagine for a second that you virtualize all of the windows, because there isn't a requirement for line of sight of the driver and supervision. It's possible that the entire cabin could possess no windows, and those could be virtualized so that when you want to see the outside world, flip a switch or push something on a touch screen, and the external cameras will simulate what's happening in the outside world and display those on the screens inside the vehicle. And so the potential to really create quite innovative and immersive digital environments where a range of different things can be undertaken and experiences can be provided. These things are opening up, and I think we're starting to see really interesting concepts coming out of a range of traditional and other causes. So second is how do these vehicles drive? This is an image from a Pepsi commercial where a NASCAR driver was taking a car salesman for a little test drive. And we need to be very sensitive to the fact that different riders are going to have different expectations in the same way that there's a wide variation in how comfortable people are driving their own vehicles. And so like a good limo driver, these highly automated vehicles will need to adapt to the comfort level of passengers inside the cabin. And this is really where technology like Affectiva's plays an incredibly important role by understanding the emotional state of the passenger and in real time providing that feedback to the automated driving system so that it can adapt not only the way that it drives, but the way that it communicates with the occupants of the vehicle to either put them at ease by explaining a little bit more about what it's doing, what it's intending to do, that it's seen other vehicles on the road. So this is going to become an increasingly important part of these automated mobility services. And I think related to the in-cabin experience, a challenge for a lot of people is developing nausea while in a vehicle and trying to do some activity that doesn't have them looking out the window. So a number of people, myself included, I'm absolutely fine while driving, but if I try to work on a laptop or look at a mobile phone for more than 10, 15 minutes, mild nausea sets in. And so there's really a lot of work that needs to be done technically by car makers to improve the ride experience, focused on people that are not looking out the window, potentially looking at screens, doing work, trying to relax and consume content. And that ties into how the automated driving system is going to function. And so figuring out what those feedback loops are and how different individuals who may have different sensitivities to it can be given the optimal experience is really an important part of what happens inside the cabin. So third, there's a question of what one can do inside these cabins. And I think this is tied to the physical design of these vehicles that I was talking about previously. Here you can see a vehicle concept presented by Toyota at the Consumer Electronics Show earlier this year. And it's very much like a sort of flexible, mobile office space, relaxation space. I think this individual in this case is doing some robot creation, fabrication activity, but it really, I think Toyota did a really good job here of illustrating that when you think about this as an entirely new paradigm, it opens up a whole range of different possibilities for what you can do in that vehicle. A lot of that will be driven by digital content and digital customization. And this is an area that Renovo spends a significant amount of time thinking about as the operating system for the vehicle. We need to safely and securely and reliably manage the automated driving system. But as the computational workloads associated with these non-driving functions and digital experiences for passengers become more important and differentiated, they need access to resources on the vehicle, connectivity, appropriate permissions for different users at different times. And so this becomes a really quite complex but very interesting and rich environment to develop for and navigate. And the fourth and final element is personalization of the cabin experience. And this really spans the prior three points, that the different physical configurations mean that potentially, if you're not buying a vehicle, you will be able to summon a particular type of automated mobility service for a particular need. One of the challenges with individually owned vehicles is that we typically buy something that will meet a wide range of our use cases, from commuting between home and work by ourselves, requiring essentially a single seat, to moving our entire families with equipment, to driving up into the mountains, and potentially going off-road. With automated mobility, the potential exists for a wider range of physical designs, so that personalization doesn't happen just in a single vehicle type, but actually in your selection of vehicle, as this becomes a more dominant paradigm. Once you're in the vehicle, these digital experiences should adapt, should be customized, and should be flexible to really provide not only a seamless continuity of your digital life. It's work documents, it's content, your favorite streaming service is linked into the screens, and perhaps content that you're halfway through Game of Thrones, and it would pre-cache some of that content so you could finish it on your long commute. All of these things will really contribute to these vehicles becoming a very rich and important third space outside of the living room, outside of the smartphone, and the work context, desktop or laptop. So those are really the four things that we believe are really exciting dimensions for building these new in-cabin experiences. And in each one of those, we're really excited to be working with Affectiva, because not only the operation of these vehicles requires input from the passengers, understanding their levels of trust, their levels of comfort or discomfort, what are the things that are surprising and delighting them. But it's also the development of these vehicles, understanding where to place things. And so having tools like Affectiva that can provide input in the development phase, which is where many companies are right now, is really quite invaluable to seeing this technology mature and advance. And I think the final thing that I want to show is really, before we get to the point where all of these amazing experiences and opportunities for customization and new cabin experiences emerge, it's really important that the systems that we build are safe. And so one of the first applications that, that we've worked on with Affectiva is using their technology to monitor the safety driver. So in a development context, frequently a safety driver will exist in these highly automated vehicles to monitor and supervise the operation of the automated driving system. And what they do is generally quite a boring task, but they need to be vigilant and need to be ready to potentially take over if something abnormal happens in the environment, or there's an issue with the system itself. So in this video, you're seeing Affectiva technology monitoring a safe driving one of Renovo's vehicles, and ensuring that their attention is on the road, which right now is happening just fine. Brief distractions, looking down to a console, changing a volume or something, is minor, but you can see there the safety driver is starting to get significantly distracted for an extended period of time. This is something that technology can really detect, and in our case is linked back into the vehicle control systems, so that if the safety driver isn't vigilantly watching the road and ready to take over, the vehicle will give them warnings and then ultimately come to a safe stop. And so we believe there's massive potential for not just the economic benefits of automated mobility to really change transportation, how we use it, who gets access to it in cities, but to provide these novel and dramatically improved journey experiences. And that's really, our focus. That's what guides us at Renovo. And working with partners like Affectiva is incredibly exciting as an operating system builder. We're a bit like plumbers, so we make sure things work together, but we need these brilliant technology nodes to actually realize some of the potential of these services. So with that, I hope it's provided an interesting dip into the potential of automated mobility, some of the areas to think about when it comes to in-vehicle experiences. And with that, be happy to open it up to some questions from the participants.
Excellent. Thank you so much. It's a fantastic presentation, Damien. We're getting a few questions for you, so I'll field a few that we have time for. And reminder, if you do have a question, please use the Q&A chat box on the bottom right of your screen, and we will answer them if we have time. The first question I have here is, can you please go a little deeper on personalization? And it's kind of a two-parter. So first off, how do you envision this can be technically implemented? And second part is, do you think people can customize how they want to be alerted if they are distracted or falling asleep, for example?
Yeah, so a big part of customization is going to depend on vertical or more horizontal services. And so you can imagine a situation where a ride-hailing network really has your preferences. Those would be the companies like Lyft and Uber. The question is then, how much do they know about your preferences? And when they provide a vehicle, how much of those preferences can be configured in that vehicle? This is the view that we have, which will be, you'll have separate demand aggregators from fleet operators. And so the interoperability between those two is really important. On the question of what those preferences are, it could be things as simple as what is the temperature that you like to have in a vehicle so that it can be cooled or heated to that precise point by the time it arrives to pick you up. It could be things as simple as, do you like music playing? Is there content that you would like to see in that vehicle? Where it starts to get a little bit more complex and interesting is things like motion sickness. So each of us as humans is slightly unique in how our vestibular system works and our proprioceptive system, how we respond to things. So it's possible that the vehicle could actually operate in a manner and potentially provide cues that are specifically tailored to avoiding you as an individual feeling motion sickness. So there's a whole range of different things and probably customizations that we haven't really contemplated yet that will be pushed into the vehicle. And the second part of the question was, could you customize the vehicle interaction with you if you were distracted or tired? So I think outside of the safety driver context that I showed in the final video, Renovo's focus is really on vehicles that aren't driven by individuals. So I think there's really, really important work to be done in making sure that the people that do drive vehicles are alert and engaged. But you can imagine a situation where you get into one of these robo-taxis and you're feeling a little bit sleepy. Do you want to have personalizations so that the vehicle, if you are napping, it increases following distances so it doesn't brake as aggressively and you get a really good 35-minute nap without too many aggressive accelerations or decelerations, and then it wakes you up with some nice soothing music to make sure that you're ready to get out when you at your destination.
Great, thank you. Okay, another question that we had come in, do you think it will be possible to detect cognitive emotional states of people outside the vehicle, and is this important, or I guess what is the use case for something like that?
Yeah, I think it's a great question, and this is something that we are actually actively working on with Affectiva. So these vehicles have a significant number of exterior cameras and a lot of processing power. For the next probably 2 or 3 decades, they will operate in environments in cities where you have pedestrians, you have cyclists, you have human-operated vehicles. In San Francisco Bay Area, you may have people on unicycles, lots of scooters, and other strange contraptions. And so the automated driving system really needs to understand those dynamic objects that are outside of the vehicle. The emotional state of humans can be a very important signal in understanding what they might do and what they're likely to do. And so we think that that's a really important signal that if it can be reliably captured, can feed into the system in the automated driving stack, which is called agent intentionality, to really understand what some of these vehicles, cyclists, pedestrians are likely to do outside of the vehicle.
Cool. Okay, excellent. I think we have time for one more. So curious on what your thoughts are in regards to the impact of robo-taxi adoption for public transportation. Do you think that robo-taxis will augment or eventually replace things like trains and buses, especially in cities? Or would this kind of in-cabin technology not work as effectively with multiple occupants on a bus, for example?
Yeah, I think it's a really good question. I would encourage if anyone on the webinar is interested to look at a piece of work done by the OECD ITF, which simulates using survey data and trip data for the city of Lisbon in Portugal, and they did a follow-up on Helsinki in Finland. And it was really addressing exactly this question. When you automate vehicles of different sizes, so everything from an individual robotaxi to automating a full city bus, and the estimated price of those services, what does that do to existing public transit infrastructure, particularly metro systems, but also to how people use bicycles and walk, which is a really important part of getting around cities. And it turns out that as the ubiquity of these automated services increases, the utilization of public transit assets actually goes up. And part of the reason for that is for a lot of people, getting to a public transit station can sometimes be a little bit of a challenge. And if you have to ride a bike and there isn't bike parking, or you can't take the bike on the train, it's a bit of a challenge. And if you have to hail a ride-sharing service or a taxi, that can be cost prohibitive for certain people. But if as I was showing earlier, the cost drops by more than 75%, it becomes this reliable first and last mile link that can actually boost ridership on public transit systems. And I think there's a cost and there's a time metric. And so I take, for example, my home city of London, that even if all the vehicles on the roads were automated, the fastest way sometimes to get across in most instances is by taking the underground. But there's certain locations, and you may live in a place that isn't close to a tube station, in which case, if it's raining, which it often is in London, it can be a bit miserable to walk or take a bike. And so if you had a robotaxi that could do that first and last mile, and it could do it cheaply and reliably, that can really encourage uptake of public transit. So I really commend that study to anyone who's interested to take a deep dive into the potential implications, which are positive. And then the second part of the question is personalization when you have a shared model. So that could be multiple occupants in a robotaxi or larger shuttles and buses. And I think this is a quite an interesting physical design challenge. When you think about how vehicles are physically designed today, it's really for people who know each other and for families and for them. And again, with this sort of more blank canvas, is it possible to have multiple entry points to a vehicle and perhaps passenger separation, so that you can have two or more people in the same vehicle on largely the same gender profile, but isolated and customized. So I think there's some really interesting things that can be done there. There's also the potential to bring strangers together. One of the great things of public transport is that people get exposed to each other that they wouldn't ordinarily if they were just driving their private vehicles. And so having services that allow you to do that and sort of match you with interesting people, or just generally expose you to that, and we can have a few human conversations that aren't involving technology. So I think all of those are possible. The kind of future on that is unwritten, and I think there's going to be a huge amount of innovation, and we will see flourishing of lots of ideas, and the ones that work will succeed. And I think it's a really exciting space.
Excellent, great. So that's just about all we have time for this event. I wanted to thank you, Damien, for your time today, and for all of you joining us, and for your questions. We tried to answer as many as we could. It was an amazing webcast, and I certainly learned a lot, and I hope you did too. We did record today's presentation, so you should receive an email shortly with the recording. For details on our next webcast and other upcoming events, please follow us on social media, keep checking our events page, and sign up for our monthly newsletter at affectiva.com. So thanks again, and have a great day.